Yeah, all right, so hey, welcome everybody. So, yeah, Dave McGowan with Kabbage. So this is gonna be more of like a story. So hopefully we can use this to help teach some other people. Other people are probably gonna be in the middle of this process. Some people might be at the beginning of this journey, and some people might be at the end. But the idea is towards the end of this, there'll be some lessons learned to hopefully help save some other companies some time and avoid some headaches and pains that we went through. So this is about our long strain trip to data democratization. So a little bit to get started, I'm going to talk a little bit about Kabbage first, just so you have a little bit of context and kind of what our company does. So basically Kabbage started with the idea that, with access to data, we could help small businesses through lending. And so that was basically how the company started. It was using a set of APIs, connecting out to PayPal, connecting out to Amazon, connecting out to eBay, pulling data, running models, and basically creating models that came up with a probability of default to help with a lending process. But we pretty quickly realized that we could do more, and so we started collecting more data, and then we continued to collect more data. And so that led to automating things like identity management. It led to fraud systems. It led to us leaving the offline market and moving into, leaving the online market and going into the offline market with direct access to bank data. And so we started collecting a lot more data. This is kind of when our problem started. So this is going to be kind of the beginning of our journey. This goes back to like 2011, 2010 when we were starting things up. It was really easy to just sign up for bespoke. Just click the button, click the link. Everything was free. Don't worry about it. You'll end up paying for it later. But at the time, it made a lot of sense. So, but on that, there was actually a good bit of value there. It worked for Kabbage. It gave us a couple of years where things were running very well for us. So while this is somewhat of like a negative slide and somewhat of a lesson, part of what we'll get to towards the end of this deck is what makes sense for a company at any given time, and not to over-architect things. So, so we joined bespoke. We actually ran our own instances on EC2. We actually started out in AWS fairly early on. This was our runtime database. It was also our warehouse. We used it for all of our data aggregation. We used it pretty much for everything. So it was a combination of MVC and C# APIs, an MVC front end with a SQL Server back end. Pretty quickly, we realized that this was limiting our data scientists as they were doing a lot of transformations and pulling data out of this SQL Server and having to put it in all these different locations. A lot of it was ad hoc solutions like on their laptops or ad hoc EC2s that they were bringing up in our development environments. And we were kind of losing control of data integrity, as well as we weren't really helping to create a system that was really working for our data scientists and our analytics teams. So that's when we made the decision to start working with Cloudera. Cloudera is what we selected. So this solution also worked for us for a time, but it also came with a whole different set of problems. So it allowed us to keep using our SQL Server for our relational store, so our primary transactional database system, but push all of our raw API responses directly into Hadoop. And from there, our data scientists could do a lot more data discovery with all their machine learning as they were building out their models. But pretty quickly, it created more problems than it probably solved. So it helped the data scientists, but it also made it very difficult for us to get the data back out of there for our other departments, such as like marketing and our other systems to run analytics on these systems. And so we had there was a very specialized skill set that was needed to be able to use these systems. Not to mention, as they started to create models that used different aggregates and different data components that were things that were not stored in our relational store, we had problem executing those systems in our runtime database. So our runtime system was still running on SQL Server, whereas all of our data science and analytics was running in this Hadoop cluster. We also ended up building it as a physical system, so that was a massive lesson learned. A 20 terabyte, 12 node physical cluster. We grew out of it really, really quickly. So that was a bad decision. But we learned a lot from this, and we kept moving forward. And so we decided, this was the time where we knew that we needed to re-architect things again and create like another solution. So we started going into the world of like POCing just about everything. So we continued down like, can we do Cloudera a different way? Was it just our implementation that was the problem? We started doing a lot of work with Kafka, and some of that's with persistent streams. Some of that was just as a transport mechanism. We also started looking for generic ways for data ingestion, and that's where like Goblin and other solutions come into place there. And we played around with Mongo for a little bit. It didn't really make the list. We played around with Cassandra, and so we were just basically at the end we decided that we wanted to bring in someone to kind of help us make some of these decisions, because when we put up all of our pros and cons, they all have pros and cons, and there wasn't like a clear winner in this POC and this bake-off. So we actually ended up bringing in, originally we did a good bit of consulting, and we found it pretty unhelpful. Everyone was kind of pushing towards, like EMR, stick with the Cloudera, stick with HDFS, and it was a lot of things that we already knew. So we ended up actually having a hire, and the hire was someone that came from MapR, and so we heavily invested in MapR and the Kappa architecture. And we spent a good 18 months building out a POC on this system. And to be honest, in the end, while we learned a lot, and there's pieces of it that we're going to continue to use, as we'll continue, we realized that this also was a failure for us. So one of the assumptions that we made along the way was that one system, which is what we wanted. So this data democratization also was not just about getting data to everyone in the company, but it was also about having a single source of truth of data to where everything can feed and run off of. So we tried to shove all of our problems into one solution. And what I would say we learned from this, and a lesson that I would hope others can pick up from this, is that it's okay to have multiple solutions to problems. You can still come up with ways, and there's some slides coming up where I'll go through some of this, to still have a central data store, and it can still be your primary store, where you don't have copies of data everywhere and you're not worried about people, whether or not they're looking at the right versions. But trying to shove everything into a single solution was a big learning that we got from this exercise. Not everything made sense for streams. Streams didn't work well for batch. Persistent streams were a problem when it came with like European data and like right to forget, and then you want to go like remove a user, and that user's data is all mixed into a stream, and I don't really want to wipe the entire stream. So there was a lot of different problems, and we had solutions for a lot of those, but it was getting really complicated. And also when we built out this system here, and well, one other point on this slide here is the idea was single ingestion, everything run through the streams, everything was going to be stored in MapR, and then everyone could use whatever view they wanted. So if you wanted to use Influx, you wanted to use Druid, you wanted to use Orango, you wanted to push it out to a Postgres database, whatever you wanted, it was fine. That all made sense on paper and in our diagrams when we started to outline this. It was like, if the analytics team wants this type of data, we can just point this, do a mapper and like point it out and build them out their own schema, and they can hook up their own tool to that, and everything will be great. But it ends up all those departments don't really want to operationally support all those systems. So we found that we moved into an operational nightmare here. So this MapR instance was running on our own self-managed EC2 instances that we were running. So we were in AWS, we did have elasticity, we did have scale, but we found out, I would say about 70% of the actual data team was spending their time doing operational work, updating systems, patching systems, keeping systems running, and it was also draining my DevOps teams, which were also at the company to support all of our feature development teams and API development and our corporate IT systems. So it was a massive drain on resources. So, one, it was, we had, 3 column store databases and 2 time series databases and 5 different relational stores, because we kind of let everyone come in with the model of, if we have all the data in this centralized location, you can create whatever view you want. That was also a bad idea. So kind of along the way here, there is an end here where we came up with a few good ideas. But what this is to be kind of like a lesson of some things that we learned along the way. So yeah, I mean, we want our data engineers like creating features and adding business value. We want them, creating new systems, helping the data scientists create more models, pushing out features to the company, not running patches and updates on systems. So basically, what this came up with is, one, I'll show you, this is kind of a growth that we were having. This was kind of just to illustrate some of our issues here. We were steady at around 10, somewhere between 8 to 12 terabytes of data. 2016, we started to see an uptick, and in 2017, we're seeing a massive growth in the amount of data that we're having to pull in, on a nightly basis. And this is due to a couple different things. The number of users that are signing up to our system, as well as the number of data sources that we're connecting to. So we're somewhere closer to 150 to 200 terabytes, give or take what you count, as opposed to originally when we were not having issues with our SQL server at 5 terabytes worth of data. So this isn't a massive, we're not talking petabytes of data here, but what the problem really was here was this growth curve and not being ready for it. So back to some of the things we talked about here, I already kind of went over these operational inefficiencies, and at the bottom really what we kind of decided was what we were going for with that MapR solution was something to be able to handle a scale and a growth that we didn't really need right now. We were solving for a problem that we didn't really have. It was more towards just solve for the next 2 years, because things are going to change between now and then anyway, and then just continue to solve for the following 2 years and just try to stay ahead of it. So this is kind of where we landed. This is our current solution that we have in place today. And again, we'll continue to iterate on it. I think someone in the presentation before was saying, every 12 months you're probably going to be doing some refactoring and there's going to be new technologies and approaches out. But where we landed here is, one, is we came to the conclusion that one system couldn't solve both of our primary problems. So our primary systems have two things that they do. We have real-time operations that need to happen, or near real-time, and then we have batch operations that need to happen. So from a real-time perspective, this is a customer comes to our website, they're filling out an application, they're giving us authorization to data sources, and by the time that they get to the end of their dashboard for a good user experience, you need to have collected all the data, aggregated the data, run n number of models, created all those results, come up with a decision and conclusion, and you need to have done all that pretty fast, sub-second for most of those systems. The limiting factor there is rate limiting on the APIs to actually collect the data. So when they land on the dashboard, they're not waiting with a multi-minute spinner, because then they're just going to close the page. So that's our real-time problems. But at the same time, at scale, I've got hundreds of thousands of users and hundreds of terabytes of data where I've got to then reprocess all of those customers on a nightly basis. And we spent a long time trying to make one system do both of those things well, as opposed to just stopping and making two separate systems for each one of the use cases and ensuring that they share and pull their data from the same place. So that was a big change that we pulled in, that we landed on, is create the right solution to solve the problem, as opposed to trying to shove everything into one. So what we've got here is our real-time systems, they push through Kafka. We do also directly have listeners that go out into Druid for more time series data. We've got Metabase listed out here, but this could just as easily be, Tableau, Grafana, name your BI tool, connecting in to do funnel metrics and marketing metrics on time series style data. But what the EMR cluster here is on that real-time system is that's where we do, data normalization, data transformations, and that happens there. We generally do that in Spark, and we do that in Scala at this point. But it writes its results out to Aurora. So, and then from Aurora, we can also give analytics back out to the company. But this also can be, connections from our data systems and our APIs and our real-time systems. So this graph doesn't kind of represent everything. It's more showing the analytics side of things. So that was a big surprise for us. Is when we started a lot of this, we were pretty certain that we weren't going to end on storing things back in a relational store when we had just come off having all these problems with, the high availability and clustering issues and scaling issues on our SQL server. But it ends up, storing all that data and getting a good processing layer that can scale horizontally. If you write the right tables and you optimize what you put into this relational store, it's actually one of the fastest and best ways for the analytics teams to actually do their job. So that was a surprise to us. This is also where Amazon, from an operational standpoint, really helped save us a lot of time. I don't have to go worrying about this Aurora cluster and upgrading the Postgres, or I don't also have to worry about going and creating my own read replicas if I need a read replica in another region or another zone. The scaling of that system. So there are some size limitations that you have there, but with our microservices approach, where we're moving more towards a lot of different services, we're a lot of different smaller databases versus one large database, we're not too worried about it, at least not for the next couple of years. And so that's kind of what we've got put in place from our real-time system. Now when you move into our batch system, it's using a lot of the same technology, except it's slightly different, but we've still got EMR, we've still got Aurora in there. I've still got my SQL server. Everyone's probably familiar with legacy systems, and it'll probably be around for a while. But once we pull everything out of it that doesn't need to be there and we optimize it for what it was originally intended to do, it's not that much of a problem. But we have migrated that SQL server into AWS. We're running it on our own EC2s right now, and eventually once we break it up, we might push it into RDS. But for here, it doesn't really show a line, but there's a line coming from both of these Kabbage systems that are writing directly to S3. This is a representation of S3. This is also a representation of SQL Server here. And then from there, it's also going into EMR. And from EMR, it's also using the same thing, data enrichment, normalization. Again, it lets us process large amounts of data really fast. The slowest part of that is whether or not we want to pay for an always-on cluster, or whether or not we want to bring it up on demand and wait a few minutes. But from the batch standpoint, we generally keep it cold. We bring it up at night. If I need 50 nodes or 100 nodes or whatever I need, I fire up what I need. One of our batch systems in our old process before we built this out, we had a job that was pushing 17 to 20 hours a night. And once it hit 24, we were going to have a problem. And in this new architecture, we've got it running in about 20 minutes. And there's further optimizations to be done there. So from there, what we do for the data science team is, this data is pretty raw. We do minimal normalization on it and enrichment, but we do some. And we push that out into different S3 buckets here. And then from there, we push that out into an EMR cluster that the data scientists use. And that way they get to use all their normal tools to do all their machine learning. So, some of the stuff they're doing in MapReduce still, some they're doing in PySpark, and some are, doing some stuff in Scala and using various libraries and tools. But at the same time, at this layer where the enrichment happened, where we're writing raw JSON out here for them to do whatever they want on this end, we're also still pushing things out into a defined feature and aggregate store, and we're also using Aurora for that. And then we've also thrown Presto kind of right here in the middle. And from Presto, what we've given is there's a lot of people on our analytics teams that are very familiar with SQL. They're very familiar with the syntax. This allows me to do joins and do different connections behind the scenes with a common interface. So we debated for a while on whether or not this should be an API, but we ended up with this just because of the skill sets of the people that we had at the company. And this allows them to automatically write queries, and then we'll determine where we pull the data from. And if you imagine behind here, if I added 4 or 5 different data sources, depending on, if I just give the data dictionaries to the teams here, it won't really matter. So the analysts don't really have to worry what's behind the scenes here. Whereas the data scientists are always going to run the raw. The data scientists actually generally want to skip all the way back to here, but we save them a good bit of time with some enrichment in this process. So this is kind of our new architecture that we've got. So a lot of this I talked about, this is, using Spark and EMR for our, data science environments, and, using Presto for some of our systems. So a lot of this I kind of went over on the previous slides. But this is just kind of to help with that data democratization, that layer. And you know what, Presto might not be the layer that we keep there forever, but the idea is we do want a generic interface where we do not have those users directly connecting to any of those data sources, and then we control that single data storage location, which right now we've kind of landed on that being S3. And then putting some processing in between, and then creating an abstraction layer where people can pull data out from a single interface. So I talked a lot bit about this, but a lot of the benefits here were operational efficiencies. I mean, even when we were on our, managing our own data on our own EBS volumes, or prior to that when we were in our colos and we were, managing our own NASs, just managing and like repartitioning and moving all that data around, upgrading all those systems. I mean, it was literally taking, upwards of 60 to 70% of the teams to do their job was all operational. And what we get out of Amazon is just not having to worry about that. Not having to worry, there is some maintenance that you have to do. You have to watch out for certain things, but it's a fraction of what we were having to do before. The automatic scaling, I mentioned earlier when we talked about our Cloudera cluster, and it was a physical cluster. It was HP servers running in a rack, and it's a lot nicer to be able to spin up 100 nodes in EMR when I need them, as opposed to trying to send someone down to the data center and physically rack up 8 more servers. So these are a lot of problems, which is kind of funny because Kabbage started in AWS, and then we actually moved some of our data systems into a colo, thinking we could get things that we could do things faster with metal. And then now we are on our journey, basically bringing everything back into AWS. So that was fun. So this last part here that I talked about a little bit earlier was on just picking the right solution. So the solution that we have right now might last us 2 years, might last us 3 years, but you're going to be re-architecting things every year anyway. And we spent so much time, trying to build out when we went down the MapR route and scaling out that cluster to handle, petabytes of data and the traffic and the throughput and the testing. We were solving a problem that we didn't actually have. And you know what, we were talking earlier about like BizSpark, and we were talking about how, there was issues with our SQL server, but when we actually, that system worked for us for like 4 years, and it worked fine. And then we migrated now to a new system that'll work for us for a few years, and it's all about like just not over-architecting, and solving the problems you have at hand, decreasing, any operational inefficiencies that you have, and just engineers can, and I am guilty of doing the same thing, but don't try to solve for a problem that you don't have right now, but don't not plan for the future. So we see that growth curve, and I can project where it's going to be, so I need to make sure I have a system that can handle things for a couple of years, and then I need to start next year planning for a system that can handle things after that. But we had 18 months where we invested into a system that we ended up essentially throwing away, and then rebuilt this new architecture in about 4 months in AWS. And it's already started solving our problems. Like I said, with that one job that we've taken down from about 17, 18 hours down to about 20 minutes. That already has taken a load off of our SQL servers and sped up our entire production system, and we pulled that off in about 3 months. So that's our presentation. Yeah.
David, thank you. I think you should change the title from a long, strange trip to a series of unfortunate events. But
probably so.
That was the
other
saddest.
one sounded better.
You're still standing and smiling. I have a question, and you guys have questions. Slido.com #startup. I can understand how you knew when what you were doing wasn't working. And Natalie, I want to bring you into this. But how did you know? You mentioned one thing about reducing time from hours to 20 minutes, but how did you know when things were starting to work the right way and that you were on the right path? I understand you guys, it was obvious you were on the wrong path, but when did you start to know you were on the right path?
So I would say like last year when we started going down the path, and like a lot of what we learned when we started down that MapR migration, a lot of things that we learned during that process we're still using. We're still using streaming technologies, we're still using Kafka, we're still landing things out in Druid. Those were parts of that solution. So we were seeing solutions but it just wasn't actually solving our business problems. But technically, we saw value in what we were doing. What it was essentially it was when we shifted the team to stop being in like R&D POC mode, solve all of the problems for the future of the world of our system, whatever you can think of, and I changed it to, we've got these 4 use cases. I've got this job, and I needed it to run in under 30 minutes, and I need to solve this problem, and I have to solve it by the end of the year. And so really what we did was we started shifting the priorities to give more specific business cases that had to be solved and within a time frame. Now go use all the technologies that you've learned from in the past, and it was when we made that shift that we started seeing massive progress.
When you made that shift, was the relief or the success obvious, like from the get-go? And
yeah, it was definitely obvious. I mean, so you can immediately go from not having to do like SQL Server maintenance windows because you've taken a load off that server from an IO standpoint. So like, my SLAs, my uptime are automatically up. Fewer, missed ETLs and transforms and packages.
Right.
You've got like data loads that were late going into like Salesforce or, different email marketing systems. And all of those things are starting to be more reliable. And so the entire company, like just by fixing one job, which was hammering and taxing a database every single night, which was then having a trickling effect on downstream jobs, which affected the entire business. By solving that one problem, the whole company felt the success of that project.
Wow.
Yeah.
All right, let's get to this questions here. Any plans to increase the frequency of data refreshes?
Yeah, so if it was up to us, we'd have everything. We wouldn't have any batch. So we're actually working with some of our vendors to get more event-driven callbacks into our system, so we get data all throughout the day. The problem is there's certain data sources that we collect data from that will probably not create event-driven callbacks to us, where we will have to do things in a batch mode. So there's legacy banking systems and reporting systems and things that we call from a fraud standpoint, where frankly they're probably still running on mainframes and they're doing nightly batch processes themselves. So, but everywhere we can, we want to move everything closer to the real-time architecture and do as little in the batch system as possible. But we did need to build a robust batching, a batch architecture system because it's a problem that we know we're going to have for multiple years. So.
Question from Meg. Who's Meg? Raise your hand, Meg. Meg.
I'm going to let you answer this one.
What do you use for orchestration?
Yeah, all of our, previously we were using Chef for everything. I think we're still using a lot of that. We're moving more towards like Terraform and some confirmation stuff, but largely Terraform. So yeah.
Good for you, Meg. It seems like you evaluated everything, but did you evaluate Redshift versus Aurora or Druid?
We did. Right now, Aurora made sense. We like the... Aurora made sense for what we're doing right now. So because of the SQL syntax and all that stuff, it made sense for right now, I guess is the point.
Can answer that second part of the question too. Why not HBase on EMR rather than Aurora?
And so one thing on the top, one thing I do have to unfortunately deal with right now is we have partners that use our platform in Europe and South America and in Canada, and primarily Europe right now. I'm working on changing them. But some of those banking partners that we work with don't like AWS right now still. Everything's different. So in the last 3 years, there's been this massive transformation. We've got them running their QAs in AWS and things like that. But one of the reasons why we pick certain things like, so for example, even with like EMR. So when I go to run that in a colo, if I do have to install that into a data center in Europe, I can bring up my own Hadoop cluster and I can rerun all my Spark code and I can reuse just about everything I have. So one of the reasons to go with something versus, like in Aurora, we pick it with like Postgres compatibility mode, so I can install my own Postgres instance. So Redshift is kind of one of those tools that if I go all in, it's very much Amazon based. So I do still have to pick certain tools while managing getting the benefit of AWS, still allow me to, with minimal effort, run that technology within a colo if I have to. So that drives some of these decisions that come up in some of these questions here. So.
Does that drive the HBase on EMR rather than Aurora decision as well?
So, do you want to answer that? Or?
In this case, Aurora, we actually still have HBase on our Cloudera cluster that we're still still using. But for this particular use case, we needed some like more, I guess, it was a little bit easier to load in. It was a little bit easier to manage for people that are working with databases, just standard RDBS kind of stuff. So yeah, that's why we went Aurora for this particular one.
I mean, we have a good many people that already knew Postgres, and there are some slight nuances between HBase and Postgres. And, you know, we mainly picked it based on the skill sets that we had. There were lots of conversations and some POCs done on, you know, using S3FS and pulling the data directly into EMR, and then not having to push that data back out into Aurora and actually make HBase tables that we could actually hit direct. And that is something that we will continue to investigate. But it was a pretty simple transformation to push it out into Aurora. We actually also found that one of the benefits is we need a good many read replicas in multiple regions for our different office locations. So from San Francisco to Bangalore, as well as some of our partners in Europe. And they need read-only replicas with certain rules, and some of the benefits that we got from Aurora made that very easy, where that is a little bit more difficult to do in EMR, which is where we would be running the HBase system, so.
Kent, where's Kent? Kent, all right, this is a long question. You mentioned provisioning EMR capacity for bulk jobs. Did you leave master and cores running or create new clusters?
So we do both. So we've got a small, long-running cluster that we use for the real-time system. This is the current solution that we have right now. It's because we can't script up the auto-generation of that real-time cluster fast enough. I lose a few minutes. And in that real-time scenario, those minutes matter. So we have what we call like a real-time EMR cluster. Right now, I think we've got it around 4 to 6 nodes. But everything that we do in batch, since the minutes don't matter, those are straight, fresh clusters that reload their data and run every time we actually build them out. So we're actually doing both.
All right. You heard that. Do you use AWS services for data cleansing?
Not currently. Right now, all of that's custom code that we've generated. We are definitely looking into tools to do some of that more effectively. But most of what we do right now from a data cleansing, data normalization standpoint is a combination of stuff that we've written ourselves either in Python. A good bit of it's, some of it's directly in Python, some of it's in Python that we run within PySpark, and some of it's in Scala that we also run in Spark ourselves. So.
How do you validate data is accurate?
Well,
how does anyone validate that data is accurate? This is an existential question.
Yeah, that's kind of hard to do with 100% accuracy, but we have checks in place where what we do is a lot of for all the stuff that comes in from like an ETL batch standpoint, after we pull in all that data within our systems, we generally have something that's going to re-export that data back out, and then we're going to do a mapping exercise, and we're going to do validation, data validation from that perspective. We also do like schema validation before we actually send anything out. And when it comes from like an aggregate perspective, it's generally a combination of like reviewing the code as well as then running over large data sets. So if our data science team comes out with like a new model, creates a whole new set of features and a whole new set of calculations, we're going to run those calculations in 2 different systems. So they'll be run within that EMR cluster, and then we'll also run them within a separate production cluster, and then we'll do baseline comparisons between all those values. We have had invalid calculations make it into production before. So, there's only so much you can do. One of the things that we've spent a lot of time as we refactored stuff, so in the old days, we had a lot of stored procedures that were performing 50 different functions in a single sprock, that were calculating a lot of aggregates, performing a lot of business logic. Couldn't check that stuff into source control, couldn't have multiple people working on the same time. As we moved all of our jobs into Spark, we've moved more towards every aggregate and every feature is its own independent function, so I can more easily unit test it, and then I can get it into source control, I can peer and code review it. So just process changes and changing the language and the technology has made a world of difference in the data accuracy. So.
Do you still use MVC for your front end?
No, we use
Why?
Because we had a lot of people that didn't enjoy working in it. We switched over a couple years ago, and We have all of our front end in Angular with our middle layer in Node. We were actually pretty early. In hindsight, maybe I should have picked React, but we jumped on Angular too. And then we followed that whole journey where they rewrote it 3 or 4 different times as we were trying to get our application launched. So that was fun, but we came out the other end, it stabilized, we stayed current on our Angular. We've got our app fully segmented, running in containers, running in AWS, and a completely separate VPC, so it's forced to not break any rules and only use our microservices to pull data out of our platform. So that deployment and that CI/CD is fairly clean. Our middle layer is still in C#. Just for speed, a lot of it we've started to convert over to .NET Core and individual microservices so we can actually get those into containers and run those on Linux hosts and get those deployed as well. And then our backend, you saw in the slide on a lot of what we're changing in our backend. So,
I'm going to ask one more question. Both of you seem pretty unflappable, but you're talking about DevOps hell and and then that didn't work. How did you manage? How did you get through it?
We have a lot of beer on tap. It works pretty well.
Yeah, that helps. I mean, it's just part of it. I mean, I think everyone probably goes through this. Maybe they just don't put it up on a slide and then come show it to everybody. But part of this being, the theme of this with startups is, the hope I had with the, being blunt and direct with that journey was it would help someone avoid some of those mistakes. I think a lot of people are going through those same things. They're probably just not talking about it. And if they're not going through those things, then they're probably not taking enough risks and they're probably not experimenting enough anyway. Like any engineer, when they go out and they go build things, most of what they build is probably going to get thrown away, or they're going to fail, or they're going to learn from it before you end up with that great solution. So I actually find all those mistakes just a normal part of the software development process.
Well, David and Natalie, Kabbage, thanks for sharing, and thanks for being so honest. Thank you, guys.
Yeah, definitely. Thanks.